Hello my dear students, welcome back to NEET World. So here in this session we will be discussing states of matter 4 marks questions. Okay, so this is for exclusively for IPE for both Telangana and AP students. Okay, and here this is our material, C60 material. Yeah, you can access this material for free of cost from our NEET World app. Okay, now this material contains all important questions from all chapters of first year as well as second year. Separate book is there for second year students. Okay, along with chemistry you can also access physics, biology for BiPC students and mathematics for MPC students. Now what you need to do, just go to Play Store and download NEET World app. Okay, then log in using your mobile number. Okay, then just mention your class and group in the chat box. Then our team will guide you how to access this material for free of cost from our website, from our app itself. Okay, right. Now if you observe, this first year syllabus contains, question paper contains very short answer type questions, that is VSAQs, SAQs and LAQs. Okay, see all LAQs are covered already in this playlist, in this channel itself. Just go through the playlist, you will be having first year LAQs, first year SAQs, first year VSAQs, similarly for second year also for all subjects. Okay, and mathematics, physics, chemistry and biology, physics, chemistry. Okay, SAQs also covered, and in this session I will be covering SAQs, that is from states of matter. Okay, that is from states of matter. So from these states of matter, okay, you can also expect a very short answer type questions also. It means all the very short answer type questions, that is 2 marks questions, are already covered. Okay, if you haven't watched them, you just watch them, you will definitely feel confident about your preparation. Okay, right, and we are very close to the IPE exams in Telangana, right? So if not yet covered, please use these live sessions and make your preparation more effective. Okay, right, let's start our discussion on the states of matter. Okay, so if you see the 2 marks question, so there also we can expect something like what is an ideal gas equation, okay, or what is Boyle's law, Charles' law, Avogadro's law. This kind of questions we can expect as 2 marks question, and similarly the combination of all those laws we can expect as a 4 marks question also here. See, the first question says here, derive an ideal gas equation, derive the ideal gas equation. So what is ideal gas equation? First of all, we know there is something called PV is equals to nRT. Okay, this is what ideal gas equation we got. Okay, now this is a combination of some other laws like Boyle's law. These are very fundamental laws. Boyle's law, Charles' law, Avogadro's law. So combination of all these laws gives you this ideal gas equation. Right, now let's study one by one what these gas laws are explaining us. Okay, right. So first of all, when it comes to Boyle's law, okay, so Boyle's law says that P, that is, let me change the color of pen. So it states that pressure is inversely proportional to volume. Okay, what is inversely proportional? Pressure of a gas is inversely proportional to its volume. Okay, that volume occupied by that gas. Okay, so now this will be valid at constant temperature. What is constant temperature? For a given amount of substance, it means number of moles also constant. It means for a given amount of substance that we have taken in a container, let us say. Now at that particular temperature, pressure exerted by that gas is inversely proportional to the volume of that container. Okay, so greater volume, lower the pressure, lower the volume, greater the pressure. Okay, this is what we will be seeing in our daily life also, right? So yeah, this is about Boyle's law here. At constant temperature and number of moles, what are the things are constant here? The amount of substance, that is indicated with the number of moles. Okay, remember these are the 4 terms you need to remember now, P, V, T, N. So these are the 4 terms we have. So in each of these gas laws, out of these 4 terms, every time 2 terms will be constant. Out of these 4, 2 are constant, remaining 2 have some relation. Out of these 4, 2 will remains constant. For example, Boyle's law, if you observe, these 2 are constant now. T and N are constant, that amount of substance, number of moles and temperature is constant. Now there is a relation between P and V. Similarly, when it comes to Charles' law, So at constant pressure, so what is constant in Charles law? P is constant along with the amount of substance. P and N are constant. Now volume of gas is directly proportional to temperature. Okay, so at constant pressure, okay, and amount of substance is also fixed. Okay, V is proportional to T. This is about Charles law. Okay, right. The next one here is Avogadro's law. So Avogadro's law, the volume of gas or the volume of a gas is directly proportional to the amount of substance. That is nothing but at a constant temperature and pressure. What are constant out of these four terms? Now here pressure and temperature are constant. In Avogadro's law, pressure and temperature are constant. At a particular pressure and temperature, the volume of gas directly proportional to amount of substance. It means more amount of substance present, more is the volume. That is what you need to understand here. See, let us say this is a container which can be expandable or compressible. Okay. Now I am increasing the amount of substance in this. Now what happens if we increase the amount of substance at constant temperature, okay, and pressure? Now whatever the amount you are increasing, now what happens, that amount, as amount increases, that volume of the container also expands, now like a balloon if you take. So just take a balloon and you just insert some gas in it. What happens? It will expand, right? So that is what here Avogadro's law means. Okay, V is directly proportional to N. Okay, that's it. Okay, so now by combining these three, what we are going to get, what are the three things we have now? P is inversely proportional to V, you have seen that. Okay, and then next here P is inversely proportional to V, we have seen. Then next here V is directly proportional to T. It means I am writing this P, V directly proportional to T now. So here it is T. Okay, like this if you write. Amount of substance means you can put N because V and N are directly proportional. Okay, so from this what we got, PV is directly proportional to NT. So if I remove that proportionality and replacing some constant, let us say K or R, NT. So PV equals to nRT. So where N is called universal gas constant. So now this R has different units. R has different units. Now how do we get this R value? R equals to PV by NT. So for 1 mole of substance at a standard conditions like specific temperature if you consider, okay, and here pressure if you consider and volume also consider, we are going to get R value. So at STP conditions like that if we consider, R is going to be like R is equals to 8.314 joule Kelvin inverse mole inverse. Okay, you no need of deriving all those things, you just need to write the steps. Okay, finally you need to represent that PV equals to nRT and you just mention what is the R value here. So R is called universal gas constant and R has a different values like with the different units. R equals to 8.314 joule Kelvin inverse mole inverse, or R equals to 0.082 liter ATM Kelvin inverse mole inverse. Okay, or in calories R can be like approximately 2 calorie per Kelvin per mole. Okay, these are the units to be mentioned. Okay, any one at least if you mention, yeah, it's really good. Okay, up to here is this clear? Do you have any confusion in the discussion? Right, if no discussion, let's move forward. That's it. Okay, so now what do we mean by P? P means pressure of gas, V means volume of gas, number of moles of that gas, T is absolute temperature. It means you should express T in terms of kelvins. Okay, so R is a universal gas constant. That's it. If you mention this, yeah, it's enough for 4 marks. Okay, write the postulates of kinetic molecular theory of gases. Okay, see, we can expect a question either directly from the postulates of kinetic theory of gas equation, or we can expect using kinetic theory of like kinetic theory of gases, we need to derive Boyle's law, Charles' law like this. Okay, I will explain that question also. Okay, now look at this. In order to go further, you need to understand this question first. Write the postulates of kinetic theory of gases. So the first postulate here is gases consist of large number of very small particles, identical particles. Let us say I have a container here. Okay, so in this only nitrogen gas is filled. What I am saying? it is filled with a nitrogen gas. So it means nitrogen gas is nothing but it contains only N2 molecules now. So this is a, see, every gas contains a huge number of tiny particles. Yes, this container now contains huge number of nitrogen molecules, that is tiny particles here. Okay, now all these particles are having similar same properties, like their sizes are same, all of them are identical, like they have same size, same chemical reactivity, same mass, everything is same. That is what the first point says. The actual volume of gas molecule is negligible when compared with the volume of container. See, volume of container is this much big, I am saying. Now here we have lot of gas particles now in this, lot of gas particles are there like this. So now what I am doing is, so just compress all those gas particles here. Let us say they are coming like this, you are pressing this side, this side. So all these gas particles now just occupying this much of space. So it's very small space now. So that is what, when we compare the actual volume of gas particles with the volume of container, the volume occupied by the gas particles is almost negligible. Okay, the actual volume of gas molecules is negligible compared with the volume of container. That's it. Okay, next one, there is no attractive or repulsive forces between the gas molecules. So as per this kinetic molecular theory, what they will say is there is no attraction between the gas particles. See, if this is a gas particle, if this is another gas particle, like this we have n number of gas particles now, between them there is no force of attraction or force of repulsions. Okay, so now what they are saying, there is no attractive or repulsive forces between the gas particles. Okay, at normal temperatures and pressures. Okay, now again these are in continuous random motion. Now these gas molecules are in continuous random motion. Yes or no? In that is true only, no? So in the nature also, if you observe, these gas particles will move random motion right now with some random motion. So gas particles, gas molecules are in constant random motion in all direction. They move in straight line, collide with each other and with the walls of the container, right? This is perfectly correct, no? Yeah, so this is the statement. I mean, you need to understand, or you need to make it clear. Yeah, you try to apply that in the daily life or practical way. You just try to understand it so that it is easy to remember. Next, cause of pressure. So now what is the, see, if I say this container contains some gas particles or it contains some gas. So now that gas will exert some pressures now, pressure on the container now. So what is the reason that for that pressure? Yeah, it's very easy. Look at here. The pressure of a gas is due to continuous collision of gas molecules with the walls of the container. See these gas molecules are in random motion now here. So now what happens, due to that random motion, the gas particles will hit the container, like this gas particles will hit the container. So due to that reason, that energy will be now what happening, they are in continuous collision and they are also colliding with the walls of the container. So due to that reason, when they are colliding with walls of the container, that is resulting to the pressure. So that is the reason for the cause of pressure. Now the collisions between the gas particles, what I am saying, collisions between the gas particles is perfectly elastic. It means when two gas particles are colliding, so it is perfectly elastic. Okay, so here you can see the collision between the gas molecules with the walls of the container and between them are perfectly elastic. Okay, and there is no loss of, it means there is no loss of kinetic energy during the collision. So there is no loss of kinetic energy during the collision. Okay, so energy may be exchanged between the gas molecules during the collision, but total energy remains constant. So when they are colliding, that kinetic energy may be exchanged between the molecules. Okay, but overall kinetic energy will not be lost or gained. Okay, it will be transformed from one molecule to another molecule due to these collisions. Okay, right. The next one here, different speeds of molecule. Yeah, so at a given time, gas molecules move with different speeds, therefore they possess different kinetic energies. Okay, they possess different kinetic energies. Okay, these are the 7 points here. And the next last one here is relation between kinetic energy with the temperature. See, as we increase the temperature, the velocity of the gas molecules increases, that is kinetic energy of gas molecules increases. So kinetic energy is directly proportional to temperature. Okay, so here see average kinetic energy of gas molecules is directly proportional to absolute temperature, that is temperature in Kelvin scale. Okay, so here, so you just remember this, K is directly proportional to T. So that is kinetic energy na Ek is directly proportional to temperature in Kelvin, that's it, you remember it like this. Okay, so now here this is again important question, just see, deduce or Boyle's law, Charles' law from the kinetic gas equation. Okay, so it's again important and easy, just follow the steps to get the answer for this. See, what is the kinetic molecular theory of gases or gas equation? We have kinetic theory of gas, we have equation as PV equals to 1 by 3 m n u square, that is RMS velocity, u RMS to the power 2. Okay, so this is square of RMS velocity. So this is what the formula we have. So where m, small m represents a mass of one molecule gas particle, okay, and n represents number of that gas particles. Okay, so now this m into n I can write capital M also, that represents total mass of that all the gas particles. Okay, so this is what the first equation you need to know here, where P is pressure of gas, V is volume of gas, m is mass of single, this small m is smaller mass of single gas molecule, and n represents number of gas molecules. Okay, u represents root mean square velocity, that's it. Okay, so now from this, here you just take it as a first equation. Okay, this is a first equation. Now second equation I am saying, we have kinetic energy formula, kinetic energy equals to half m n half mv square na, so half mv square we have, so half mv square we have. Okay, so this half mv square, and if you compare these two equations, what you are seeing in the common thing here, yeah, here 1 by 3 is there, here 1 by 2 is there, here also velocity, there also velocity, here total number of gas molecules, here also mass of total number of gas molecules we have. Okay, now what we can do is this first equation multiplying with 2, dividing it with 2. So now what happens, PV is equals to 2 by 3 into 1 by 2, like multiplying dividing means, yeah, we have this one. Okay, m n u square RMS, that's it now. So this is what we got up to here. Okay, after knowing this, see half m n u square RMS, this is nothing but kinetic energy only now. So this capital M here I already mentioned. Okay, so PV is equals to 2 by 3 K E, that is kinetic energy, that's it. Okay, that's it. Up to here it is clear now. So PV equals to Ke we got. Okay, that's it. Okay, so now from ideal gas equation what we have, PV equals to nRT for n moles, RT for 1 mole. Okay, in the place of PV I can write RT also. So kinetic energy equals to 3 by 2 PV, the place of PV I am writing RT. Okay, right. So R is a universal gas constant. No, 3 by 2 is also a constant. No, kinetic energy is directly proportional to temperature only. So if temperature is constant, what happens here? So temperature is constant, see PV equals to RT. Okay, so from this PV equals to RT now, from this if temperature is constant, kinetic energy also constant, it means energy of the molecules also constant. So PV here, see if temperature is constant, kinetic energy constant. So in the place of kinetic energy if I write this, so this PV also remains constant. It means you just see here, yeah, see PV equals to RT is there now, RT place I am writing this one, 2 by 3 Ke kinetic energy. Okay, so 2 by 3 Ke. See what is happening, if temperature is constant, kinetic energy also constant, so it means PV also constant now. So PV is equals to constant. So just read this, to satisfy Boyle's law the temperature must be constant. Yeah, if temperature must be constant, then temperature constant, then all the terms here, if temperature is constant, all the product this right hand side terms are constant, then PV also constant, then PV equals to a constant. So this is what the Boyle's law that we have derived it from this one kinetic gas equation. Kinetic gas equation. Similarly, they will ask us to derive Charles law also. So now Charles law also we need to derive this. Okay, so this is also easy, same, we need to use this equation only. So PV equals to RT we got now here. Okay, so PV equals to RT we got. So from here V is equals to R by P into T, R by P into T I am saying. See, what is this Charles law says? For a given amount of substance at particular pressure, it means pressure also constant. Now pressure also constant means this denominator is constant now. From this what we got? V is directly proportional to T, right? So at constant pressure and for an amount of substance, V is directly proportional to T. So this is what Charles law says. Okay, so we got second equation also, we got we have derived Boyle's law, Charles law from KGE, that is kinetic gas equation. Okay, what is kinetic gas equation to be remembered? PV equals to 1 by 3 m u square, that is u RMS velocity. Okay, that's it. Okay, up to here it is clear. Second question is also clear. Okay, then next, and guys, whatever I am explaining, everything is mentioned in this material. Now what to do? You just go to Play Store and download this material. First download app. From that app you download this material and you can make the preparation. So this is the same material that you will be having in the app also. Okay, so whatever I have explaining, that will be written there very clearly like this. Okay, you just go through it. Okay, so now for all these things, KGE equation you need to remember. Next question is deduction of Graham's law. So Graham's law here also you need to know kinetic gas equation, that is PV equals to 1 by 3 mn u RMS square. Okay, u RMS velocity. So from this u RMS means what you can write? U RMS is equals to 3 PV by this small m into n, I am writing capital M, that is total mass. So that comes here as a denominator. Here square is there, if it comes this side it becomes root, right now. So up to here it is clear. Now root over 3p, see, mass by volume, can we write this as density? 3p by d I am writing. So what is this? D represents here. So D represents mass by volume, mass by volume. This is u RMS. Okay, so now Graham's law at constant pressure, at particular pressure, u RMS is in proportional to root over density, root over 1 by d, that is here u RMS is inversely proportional to square root of density of that gas molecules right now. So that is what, at constant pressure u RMS inversely proportional to square root of that density of that gas. Okay, so that's it. Okay, so now here u RMS is nothing but velocity is nothing but the diffusion of that gas molecules only, now the diffusion, the rate of diffusion of that gas molecules, okay, directly proportional to rate of diffusion of gas molecules, that is rate of diffusion of gas molecules is inversely proportional to square root of density of that gas molecules. Okay, it means, so what exactly it means? Let us see here. I am taking rate of diffusion, we want to compare for different gas molecules. Let us say I have H2 gas molecules and I have O2 gas molecules. Who will be having greater rate of diffusion, I am asking. So rate of diffusion means what I told you, this is inversely related now. So more density is directly proportional to mass by, directly proportional to mass now. So here it will be having a mass of 2 and here atomic weight, molecular weight is 32. So this is smaller mass now. So smaller atomic weight means, smaller molecular weight means, so smaller mass, smaller density, greater rate of diffusion. So rate of diffusion of H2 is greater than rate of diffusion of O2. So this is how you need to understand the concept. Okay, so this is about Graham's law of diffusion. Next, Dalton's law. Dalton's law, it is nothing but, if you take mixture of gases, let us say here I have, this is a container having O2 gas, N2 gas, H2 gas, like this some gases are there. Otherwise some non-reacting gases you can take, okay, like N2 is there, helium is there, okay, like this different gases are there. Now let us say some more gases, neon gas, something like this, different non-reacting gases are there. Now the total pressure exerted by these gases, let us say gas 1, gas 2, gas 3, gas 4, like that different number of gases are there. The total pressure exerted by these gases equals to the pressure exerted by the gas 1, pressure exerted by gas 2, pressure exerted by gas 3 in this mixture is the total pressure of that mixture of gases. This is what the Dalton's law says here. Let two gases are be present in the same vessel of volume V. Okay, so V. Now what we have from kinetic gas equation, PV equals to half 1 by 3 mn u square we have now. So I am sending this V over here because V is a same, V is a constant here. So we have only P here. So now P1 for gas 1 and P2 for gas 2. I can write P1 is equals to M1 N1 U1 by V of that container, volume of that container. Similarly for P2 also. Okay. So if both gases are mixed in the same vessel, the total pressure of the mixture is P total will be equals to, that is P total is equals to P1 plus P2, that is 1 by 3V, and this same values, no, you add them because V is a constant here, that is why we taken it as a common. So that gives you P equals to P total equals to P1 plus P2 plus P3 plus so on, like this we can write. So this is about Dalton's law of partial pressures. Okay. Okay, let's move forward. Yeah, this kinetic gas equation we have already studied this, PV equals to half mv square. Yeah, you just go through this one also once again. Okay, the next one is Graham's law of diffusion. State and explain Graham's law of diffusion. Yeah, this we studied just now in kinetic gas equation. I did derivation of Graham's law from kinetic gas equation, right? So what finally we have concluded, the rate of diffusion of a gas is inversely proportional to the square root of the density of that gas. Okay, at a constant temperature and pressure. What is constant? Temperature and pressure are constant. The rate of diffusion or effusion of a gas is inversely proportional to square root of its density. Okay, we have just taken two examples like H2 and O2. So which gas will be having greater rate of diffusion? So that depends on their densities, right? So this is having lower mass. See, this is having lower mass, it means lower density, greater rate of diffusion. So rate of diffusion of H2 is greater than rate of diffusion of O2. This is what we have studied or understood from the previous discussion. That's it. Okay. So if you want to get exact values, you can take this relation. So R1 by R2 is equals to, it means rate of diffusion of gas 1 by rate of diffusion of gas 2 is equals to, you just remove this proportionality. See, they are inversely proportional now. So root over D1 in the denominator because they are inversely related, and D2 in the numerator. That's it. Density of gas 2 in the numerator, density of gas 1 in the denominator. Okay. So density is directly proportional to mass now. So you can write this also as mass of gas 2 by mass of gas 1. Okay. Like this also we can compare. Okay. That's it. Now rate of diffusion can also be given in terms of volume and time. See, for gases at the same condition, like since if the equal volumes, they are having equal volumes, if equal volumes, V diffuse in times T1 and T2. Okay. So the rate of diffusion given by change in the volume by time. Okay. So whatever the gas, like that gas will spread now. So that is what diffusion, rate of diffusion, that is R1 V by T1, R2 V by T2. If they are covering same amount of volume, that is R1 by R2 is equals to V by T1 by V by T2, that is T2 by V. So, V can be removed, so T2 by T1 will get. So, we will get as T2 by T1, that is it. Okay. Similarly, if they are taking equal time, then what is the volume covered? It means you need to get this relation as R1 by R2 as V1 by V2, like this only. Okay. V1 by V2, because TT cancel here, because we are considering at same time with a different volume right now, that is what we do. Okay, that is it. Yeah, so these are the 3 questions, these are the 4-5 questions from states of matter, okay, for 4 marks, okay, and remaining questions, that means 2 marks question that we already covered in the previous sessions. If you haven't watched, you can go and watch that session also. I hope this session is really helpful, and if you have any confusion, please let me know in the chat box. We will discuss them in the upcoming session. Thanks for watching. Stay connected with NEET World YouTube channel. Thank you.